Okay, my friends, in today's video, we're going to be talking a little bit about the sine ratio and what it really means and what it tells us about right triangles. I'm going to just take a quick look to make sure I'm recording. I am, and we are going to dive in. So these past few weeks, we've been reviewing our trig functions and how we can use them to determine a missing side. So if we take a look at this first example with the green triangle embedded in the coordinate plane, we're trying to find the height of the triangle, and we know that the hypotenuse is 10 and our reference angle is 30 degrees. So at this point, hopefully you know something special about 30 degrees, and maybe you can just do this problem really quickly. But I do just want to quickly review about how we can set up a sine equation in order to do so. So because our reference angle is located right here at 30 degrees, and we're trying to find h, which is opposite of the 30-degree angle, and we know the hypotenuse, remember the hypotenuse is that slanted side, always opposite of 90 degrees. Because we know opposite and hypotenuse, we can refer to SOHCAHTOA. And the two things that we know in this problem are O and H. So that's what tells us that we're going to use a sine equation. So we're going to do sine of our reference angle, which is 30 degrees, equals opposite over the hypotenuse. And in this case, the opposite is H. The hypotenuse is 10. And then we're trying to find the height, so we need to get that by itself. Since on the right side we have h divided by 10, we can multiply by 10 on both sides. We can multiply by 10 on the other side. That gets us h by itself. And then we can just use our graphing calculator or scientific calculator from Desmos. Be super careful using your phone, because typing these things in your phone isn't as simple as just typing it the way it looks. So I would not use my phone. I would either use a real physical calculator or use the Desmos scientific calculator. But when you type this in the Desmos scientific calculator, you should get an answer of 5. And if you already knew that, we're going to sit tight on that for a second. But the fact that the height is 5 should be something that is familiar from what you've heard in class this week. If we were going to do the same thing with this second yellow triangle, again, we have a reference angle of 30 degrees. We're trying to find h, which is opposite that 30-degree angle. We know the hypotenuse, which is 6. So again, we would use a sine equation, sine, and remember, after sine, theta is what we call it, but theta represents the reference angle. So in this case, it would be sine of 30 degrees. And our opposite would be, we're labeled with an h. We're going to use that a lot for height, so try not to mix it up with the idea of hypotenuse. I know it can be a little confusing. So h over 6 is our hypotenuse. Again, we multiply by 6 on both sides and type this into our scientific calculator, and hopefully it's no surprise that we are going to get a height of 3. So we have both of these triangles that have some things in common. They're both right triangles, and they both have 30-degree reference angles. And if we look at them, in the first example, the hypotenuse was 10 and the height was 5. And in the second example, the hypotenuse is 6 and the height was 3. Well, if we look at our sine ratio, it is O over H. So for both of these examples, if we did 5 over 10, or we did 3 over 6, both of those reduce to 1/2. And this is because sine of 30 degrees is equal to 1/2. And if you type sine of 30 in your calculator, you will get, it'll spit out a decimal, but it'll spit out 0.5. And so 30 degrees is a really awesome angle for sine, because we don't necessarily need to set up this sine equation unless you would like to every single time. We can just know that when we have a 30-degree reference angle, the side opposite, which in this case I'm calling the height, is going to be half of whatever the hypotenuse is. And the reason for that is because sine is opposite over hypotenuse, and we see in both of these situations 5 divided by 10 gets us 1/2 and 3 divided by 6 gets us 1/2. So even if I gave us another triangle just on the spot and you're like, oh great, it's a 30-degree reference angle, if I told you the hypotenuse was 30, well, we should then know that the height is 15, because in a 30-degree angle, because sine of 30 is equal to 0.5, that tells us that the height is going to be half of whatever the hypotenuse is. So that kind of already hit on the what does this mean. This means exactly what I just said, that the height, or the opposite side, but again, it's the height of this triangle, but sine of 30 degrees equals 0.5 means that in a right triangle with a 30-degree reference angle, the opposite side will always be half of the hypotenuse. Or some folks in my class said in a right triangle with a 30-degree reference angle, the height will always be half the hypotenuse. That is fine as well. Or the side opposite the 30-degree angle will be half of the hypotenuse. But that is what this sine of 30 degrees equals 0.5 means. Sorry, I'm sitting outside and they're mowing the lawn. Similarly, hopefully it makes a little bit of sense to you that as we increase the angle, so say this is my angle of 30 degrees. As I increase the angle, if I make that angle open wider, so hopefully we can see that this angle is bigger than that, the height is going to get bigger as well. So as we increase the angle, and if you do it, I usually do it with my hands, as I open my hands wider and wider, the height is going to get bigger and bigger. So, and similarly, as I get smaller, as I make this angle smaller, right, the height is going to get smaller. So for the next example, we have sine of 75 degrees is equal to 0.97. Well, what that means is, okay, sine of 30 equals 1/2. 0.5 makes it pretty easy. We said it means the height is going to be half the hypotenuse, or the opposite side is going to be half the hypotenuse. In this example, once we get to 75 degrees, which is a pretty large angle, the height now isn't going to be half the hypotenuse, it's going to be 97% of the hypotenuse, or 0.97 times the hypotenuse. Or someone in my class said the height is almost going to be the exact same size as the hypotenuse, but just a little bit smaller. Remember, if this number here was 1, it would mean the height and the hypotenuse were the same. And that happens when we have sine of 90 degrees. That's when the height and the hypotenuse will be the same. So at 0.97, something that I would think, how this would help me remember it, is saying that when I have a 75-degree reference angle, the height is going to be just a little bit less than the hypotenuse, or it's going to be almost the same size as the hypotenuse, but just a little bit smaller. So I'm not going to write that out just so I don't have a ton of space, but again, this sine of 75 equals 0.97 means to you that with an angle of 75 degrees, so if we have an angle of 75 degrees and our hypotenuse is 15, a reasonable estimate for the height would be just a little bit less than 15, because sine of 75 degrees is equal to 0.97. Hope that helps. See you soon.